Hello and welcome to another Java tutorial. We're going to continue our discussion on Eclipse IDE external tool and how to set up the native image compiler for our Java application as an external tool in Eclipse. So we said that you go here and click on this new button, and then you give it a name. Here I'm just giving it native image 17 to remind myself that this is from GraalVM 17. And then there are a few tabs here: main, refresh, build, environment, and comment, right? So main means basically main is the execution. First of all, what binary, what native application or external application are we going to execute? And we said that we want to point this to the native image binary, which is inside the home, lib, svm, sub vm, bin, and then native image. And obviously you can click on the browse file system to look for it. And then working directory, this is where we said that the way this works is that Eclipse, when you run an external tool, Eclipse creates a shell process behind the scenes in the background and then runs that. And we know that any terminal process or a shell process has to happen in a working directory, right? Whenever you run something in a terminal, you are always inside a working directory, and that's where you are. So we said that Eclipse IDE organizes the class files inside the bin directory in your project folder, right? If you're using Maven, which I will show you an example, Maven actually sets up or puts the compiled classes inside a directory called target, and then inside that there is a directory called classes, right? So all the Eclipse puts in bin, and then Maven is target classes. And the reason we point this working directory to the bin, because native image basically operates on the class file, right? That has the that has the main method, right? So it doesn't operate on the source file; it operates on the class file. And then in order to specify the class file, you have to give it the fully qualified name. And native image consider that from the either you have to specify manually the class path or from the working directory. Java type name, we looked at the Eclipse's environment variables, and we said that Java type name returns the fully qualified name of the class file, right? Which is very important, because if your main class is inside a package, then you have to give the native image the fully qualified name. And then after that, we've seen that previously after the native image, you have to also specify the -cp, the class path, and we will do it if our project has dependencies, because when you point a native image to the bin directory, it only sees the class files that are inside the current project. It is not aware of basically the class files that come from the dependencies, like a jar file or other projects inside your Eclipse's workspace. Now, if you don't specify the -cp parameter for the native image, obviously by default it assumes that the -cp dot, which means the current directory. That's why we are pointing this working directory to the bin directory, because that's where all the classes are in Eclipse project. So that's the class path. But that only works for the classes of the current project. Again, if we have dependencies, we have to specify them with the -cp flag or argument for the native image. And then you can tell the native image where to put the compiled file and what to name it, right? If you don't specify any output name, by default native image uses the name of the type, whatever you put for the name of the class file, but all the letters are lowercase. But you can manually specify the name of the output file as well. And then puts the binary in the working directory. Remember, when the native image compiles your file, the result is going to put back in the working directory, which is the bin, right? IE assumes relative path. You can specify absolute path too, right? So here I'm telling it the output, give it this name, put it in this directory, right? Actually, I'm not sure if this works for the most recent version of the native image. We can try that. If it compiles the Java project and puts the output in the native directory here, because I'm telling it from the working directory, which is bin, go one level up, go inside the native directory, and then create this executable file, right? A file that has this name. I mean, we will try this to see if this still works. In the older versions of the native image, this used to work. I'm not sure in the most recent version it also works or not. So let's head to Eclipse. Now this is our Java native image. So far we've been creating directories that are not part of our Java project, src and packages, and we manually compiled our application to native executable binary. But now we want to make things much simpler, and we want to basically use Eclipse, right? And basically let's see, we want to use set up an external tool. Let's say hello world from Java in and external tool in Eclipse IDE. All right, so we do this, and obviously now this is part of our Java project, so Eclipse already compiled this, puts the compiled file in the bin directory, which is a mirror of the src, right? And we can also run this, right? So we can go and say run as Java application, and we get the result, right? So Java development, Java compilation is very fast because Eclipse IDE compiler is very fast. But now after we develop our Java application, we want to compile this, and then we want to select and again, in your Java project you might have multiple classes that have the main method. So any of these classes can be selected as the entry point to your Java application, which is very neat. And what we want to do, we want to create a native an external tool that we just select which class is our main method, right? We select it in this visual view, in this tree view, and then the native image puts or selects this class as the main class, right, for the entry point of the application. That's why we're trying to use a setup external tool using the internal environment variables of the Eclipse. Then if we select different files, that command that runs the native image changes, because the internal environment variables of the Eclipse are evaluated based on what you select, for example, in this tree view. So let's say hello from test class 2 main method dot dot dot, right? All right, so let's create a new directory, which I'm not going to select it as part of my Java project. That's why I'm not selecting it to be a package, right? Java package means it's supposed to have source files, and it's going to be on the class path, and the Eclipse compiler will compile and put the results in the bin directory, which is a mirror. But here I don't want that, so I just want to create a directory that is not a Java package. So let's call this native, and right now it's empty. So I'm going to select my test class, and I want to set up an external tool. So external tool configuration, I have already set it up. This is pointing to the bin directory of my Java project, and it's pointing to the native image. So note that this is the older version of the native image, and I'm gonna browse the file system, and Java virtual machines, GraalVM, the most recent version as of today is 22.1, right? And then contents, home, and then lib, and then svm, substrate VM, and then bin, and then native image. This is the executable, and this is the most recent version of the GraalVM. I'm pointing it to the bin directory, and then I'm telling it compile the Java application. So again, note that we're using an internal variable of the Eclipse project location. What this means is that when I select a Java source file here, let's say test class, this will replace this project location, will be replaced by the absolute path of the project that this source file belongs to. So if I have multiple projects, I select any class from any Java file or any class from any of those projects, this external tool will automatically recognize which project it's belonging to, right? So it points the working directory to the correct bin directory. And then I'm telling it, first of all, we can also manually tell it -cp dot, because the working directory is where the classes are, right? So the class path by default is going to be dot. Java type name, that's the fully qualified name of the class file that has the main method. Remember, that's not the name of the source file, that's the name of the class file, and that's the fully qualified name. So it's not just test class. Right now our main class belongs to a package, Java native image, right? So this at runtime, when I execute this external tool, this string Java type name will be replaced by Java underscore native underscore image dot the test class, and I'm specifying the output file. And again, the name of the executable, I'm setting it to be the name of the fully qualified name, and obviously it's going to be lowercase. And I'm telling it to go one level up, go inside the native, because once we go one level up from the bin directory, remember all these relative paths dot or dot dot are with respect to the working directory. Once we go one level up from the bin directory, we are back in the project's root, which is Java native image, and I want to go into the native image, right? So we can also look at the show command. I've already selected test class.java. So it can tell me what command is going to be executed when Eclipse creates a shell process. So library Java virtual machine all the way to native image, executable -cp dot, and this is with respect to the bin directory of the project. And then the fully qualified name of the class, Java name image, native image dot test class. This is the fully qualified name of the class that has the main method, and that's the one I selected in this tree view, right? So if I select different source files here that have a public class, this will automatically change. And then we're telling it to put it in the output, go one level up, go into the native directory, and create an executable file that has this name, Java native image dot test class. All right. So this can quickly tell you whether your substitution works or not. So let's close this. All right, that's the moment of truth. We're going to run our native image 17 on this test class. So let's run this. Let's see. All right, GraalVM native image generating the native Java native image dot test class. So it's generating the executable, initializing version info GraalVM 22.1. So this is the latest version we're using. So it's starting to compile. And okay, it's compiling, building universe, parsing methods, inlining methods. Let's see if this succeeds or not. Compiling methods. And finished. And if we refresh, now you see inside the native we have this executable and a build artifact which tells us that it created an executable, and it puts it basically the relative path. So basically in this build artifact.txt, it tells you from the working directory that the native image was run, and we know that the native the working directory was the bin directory of our Java application or the Java project. Tells me that I created an executable and put it here, which is one level up inside the native directory, inside the Java native image. Now I can show that obviously this works. So let's open up a terminal right inside our Eclipse IDE in this native directory. And obviously my fish shell is running on top of the terminal. So I'm right now, the terminal is inside this native, right? So all I have to say, I can tell // Java native image test class, and this is my executable file. And hello world from Java and external to Eclipse IDE. All right. Now the power of basically this external tool and the fact that we're using the environment variables of the Eclipse IDE is that now I can quickly select another class that has the main method, right, in this tree view, and run my external tool. And I don't need to do anything else because Eclipse IDE automatically changes that shell command based on which file. Now it's telling me I'm actually compiling the test class 2. So it's very quick. So you just select which one you want to compile. And again, a single Java project can have multiple executable, multiple classes that have the main method. And you can run your native image on any of those and create multiple executable outputs, right? And that makes your development very powerful because see, it took only like a few seconds, 2 seconds, and now we get another executable. Let's go back to our terminal, and now we're going to say Java native class test class 2, and it says hello from test class 2 main method. So we developed one Java application very quickly. That Java project has 2 classes that have main methods, and we told the native image when it compiles which class has the main method, or basically which class is the entry point to the application, right? And again, we are taking advantage of the powerful external tool features that Eclipse provides, because then we can write relative or basically agnostic strings that when we run the external tool, the Eclipse substitutes these environment variables with the correct values, right? Which is very powerful. Now this works, and the next thing that we want to do is look at the dependencies. So far, the idea is that we set the working directory to bin, right? But we don't need to do that. So I'm going to, let's duplicate this. So the duplication works, every setting is the same, but instead of working directory, I'm going to tell it project location. All right. And then, but if I run this, this is going to fail because the class path is not set, because when the fully qualified name of this class is returned, it should be relative to the class path, whereas the project location is not the class path, right? The classes are inside the bin directory. So what we can do, we can actually use one of the environment variables that we previously see, and that's the project class path. All right. And then we give it the selected file, and then now we know that the native directory is inside the project location, so we use one dot from the current directory instead of all right. So apply, show command, everything works fine. As you can see, -cp already works fine. -cp works fine, so no problem there. So close. Now let's delete the previously compiled files. Select one of these, go back here. I'm going to select the second one and run. And hopefully this also works fine. So native image, compiling the Java native image .test class. So everything seems to look fine. Version info 22.1, garbage collector serial GC. So it's going to quickly compile our application. Building universe, parsing, inlining. Now what I'm going to do, I am going to, so this works fine, this finished. Let's look at our native directory. Let's refresh this, and we have our executable file, and then .java test class. It still works fine, but we changed the external tool, right? External tool now is in the project directory, and then we explicitly told the native image what is the class path, which is the recommended way. The reason is that now if we have the dependency, the first approach would not work. So if you look at the native image 17 here, we're pointing to the bin directory, and then we say that the class path is here dot, which means the bin, which is correct. But if our project has dependencies, this approach is not going to work. Whereas this approach that we pointed to project location and explicitly give it the project class path will always work, because this class path adds all the directories, and Eclipse is aware of what are the dependencies of your Java project. Now we can put this to the test. So let's delete these, and what I'm going to do, I'm going to edit my working set. All right, and then I'm going to bring another project, let's say this one, dev Java, and inside this I have a, let's say, class, right? Let's say inside it, I have this car class, right? So it has something, and I can go ahead and in test class, let's create a car, new car. Now obviously at the moment it's probably not going to recognize this. So what we're going to do, we're going to right click on our project, build path, configure build path. Now on the class path there is this dev.java, right? So if I go back to the build path, configure build path, and we can go to this projects tab in the Java build path, or you can go to project references and give it a dependency. So projects may refer to other projects in the workspace. So you can just go to project references, dev Java. And what this does, it actually puts that project reference to the build path or the class path, right? And then when Eclipse runs the run anything, it automatically puts the bin directory of this other Java project on the class path. So let's see. If I go back and look at my external tool, this one, look at the show command line. You see there is this let's see. So Java native image bin. Well, it's not on the class, so let's try to see if we can compile. All right, so in order to put this on, so I think let's try this. So right now it's the bin directory of the other project is not on the class path, but we gave it a reference, right? So all right, I'm going to actually cancel it, because so when you use a project reference, you can then quickly use the other types. All right, let's see. So it doesn't recognize that. All right, so let's go back to Java build path. On the class path, we add a project from workspace, this one. Okay. And now we can import this car type from dev Java, right? So instead of project references, you want to put them on the class path or module path. Here we just put it on the class path. In the Java build, go to the projects, and then you can select the class path, click add, and then you can select any project that you have in the workspace as a dependency. All right, in the project references, this is empty for now. All right, and then if we say car, new car, it's going to, we're going to say that the price is, let's say, 100, and then sys out car. So this car is coming from the other Eclipse project. Run. So we had some static initializers, they're called, and this is just the default to a string of the car, right? So we have a dependency. Now if we select this and run our first native image, which specifies the class path only as the bin directory, let's see if this works. So test class is going, this is most likely is going to fail because the class path doesn't include this dependency. So let's see what happens. All right, building universe, parsing methods, inlining methods. So far it's going well. Let's see what happens. And yeah, it looks like it works. That's very interesting. All right, so let's go ahead and try to run this. All right, we get an exception, Java lang no class def found error. So it looks like in the most recent version of GraalVM, it goes ahead and compiles, but then at runtime you get an exception, which is really not that. I think there's probably an option that you tell it that if you don't find any class at compile time, then fail. We will look at this, but for now it succeeds, but then the runtime throws an exception that I can't find this class at runtime, right? So what we want to do is to go back and run our second configuration, which is explicitly specifies the project class path, and Eclipse already is aware of all the dependencies of this Java project, which is very nice thing to have. So we don't really need to care about or worry about figuring out which are the dependencies of the Java project. Especially if you're using Maven, you might have lots of dependencies. That's something that I will show you in the future lectures. So this is going to recompile, and then hopefully this time it's going to work fine. Because right now we explicitly give the native image the dependencies. All right, the compilation finished. Let's refresh, go to our terminal, and let's execute the last command. And now it works, right? So again, the idea is that Eclipse is already aware of all the dependencies of the class path of your Java project. So definitely take advantage of this internal variable project class path, and obviously also this Java type name that returns the fully qualified name. I believe this is the most important part of using native image, because once you set this up one time, it's very easy to use it a lot, because you just select whatever class that has a main method and run your native image, and everything should work just fine. So I hope you really enjoyed this lecture. Please stay tuned, and I'll see you in the next one.